Hey everybody, Mr. Judson here. So we're moving into chapter 2 now, and chapter 2 is kind of nice because it's all about polynomials. Now, what's a polynomial? Well, that's anything that can be written this way. P for polynomial, it equals ax to the n, which to me just means like 4x to the fourth power, or 3x squared. You know, some number times x raised to an exponent, plus another number, and then our exponent is 1 less. And then another number, x, 1 less. So our exponents are decreasing until we get to just a number at the end. And a lot of times people just use z for that, okay? So here's some examples of polynomials. P of x equals 3x to the fifth minus 2x cubed plus x. Doesn't always have to be a number at the end. You know, if that number happens to be 0, then we just don't write it. But that's a polynomial. Here's another polynomial. X cubed plus 3x squared minus x plus 7. Okay, polynomial. That's our main focus in this chapter. And how do we factor polynomials that get a little more complicated? Well, the nice part today is it's fairly easy. We're talking about quadratics, which are parabolas. And we already know a little bit about those, right? We know how to take a quadratic expression and put it into vertex form, and then use that information to graph it easily. So I want to just tell you guys one thing that our book does. Our book uses the words standard form. And we're going to have to think of that as the exact same thing as vertex form. Okay? They both mean the same thing. That's where we write down y equals a times bx plus c squared plus a d value. Okay? Now, if I want to write it in general form, you guys might remember, we talked about this. If I say general form, then that's y equals ax squared plus bx plus c. Okay, so we got general form. We call it vertex form because when you look at it, you know where the vertex is. But for some reason, our book calls it standard form. I've actually seen before where some people say standard form is really this. I've seen that on the internet. I've seen it in books. It kind of messes things up. I mean, we just all need to be the same. But I know our book will ask us to write equations in standard form. They won't use this word. And so we just need to be aware of that. Okay? So I know we did this a number of times in the last chapter, but let's just make sure we're good. I want you to convert f of x equals 3x squared minus 12x plus 7 to standard form or vertex form. I'll go ahead and write standard because that's what our book's going to do. Okay, you guys go ahead and try that. All right, so we want to put those first two terms into parentheses and then factor out a 3. So we get x squared minus 4x. Now here I still have plus 7. And then I want to take half of this number, which would be a negative 2, square it, and get a positive 4. And remember, I got to multiply that number times 3, because once I distribute it, I now have 12. It's 12 that I just added to this expression. So I want to do the opposite of that and subtract 12 out here. And so now what I get is 3 times, remember I told you I'm going to quit writing 2 sets of parentheses, x times x, 2 times 2. And I need the sign in the middle here to match this one. 7 minus 12, that's a negative 5. So there's my expression in standard form or vertex form. Okay, so we'll get some questions that ask us to do that. So that means that the vertex is at 2 comma negative 5. That's not the only way to do this, okay? One of the things we want to look at today is there a different way that I could find the vertex without having to do this work? And there is. So if y equals ax squared plus bx plus c, you guys might remember this from Algebra 3-4, because I know you talked about it, then the vertex is at x equals negative b over 2a. So what that means is we do the opposite of this number divided by twice whatever this is. So in that last problem, f of x equals 3x squared minus 12x plus 7. If I want to find the vertex, I could just say that the vertex is at x equals opposite of this, which is 12, divided by twice this number, which is 6, which is 2. And that's what we said. You know, so where does the 5 come from? Well, now I need to plug 2 back in and figure out what f of 2 is. So f of 2 is equal to 2 squared is 4 times 3, that's 12. Put a 2 here, you get minus 24, and then plus 7. So that would be a negative 12 plus 7, that's going to be a negative 5. So there it is. Our vertex is at 2 comma negative 5. Now is that easier? I don't know. We got to decide for ourselves. Some people might look at that and go, oh, I like that. That seems way easier than what we did before. And other people will go, no, I like vertex form. And I'm going to say this, you know, as a teacher, I want to be able to show you guys different ways to do things, but I don't ever want to say, you have to pick this way because I think it's best. It's kind of like when you write the equation of a line. I told you what I'm going to do. I'm always going to do y minus y1 equals the slope times x minus x1. Not because I think it's the best, but because fewer people make mistakes that way. But I haven't told anybody you can't do it a different way. It's okay if you want to use y equals mx plus b, just don't make any mistakes. If you're making a lot of mistakes, then maybe you should think about changing. Well, same thing here. If people are like, you know what, I've got vertex form down, forget this. Okay, I don't care which one you guys use. We've got 2 different ways we can choose. All right, so something else that they're going to ask us to do in chapter 2 is when we look at a parabola. So here's my xy axis, here's my parabola. There are 2 things that are going to be important to us. One of them is x-intercepts. Okay, how do I find those? Maybe make a note to yourself to remember, these are always points. Which means they have to have an x and a y coordinate. It's always something comma 0. It's not just a number. I don't want to say the x-intercepts are at 1 and 10. No, they're at 1 comma 0 and 10 comma 0. All right? So that's one thing we'll talk about here. Another thing, well, we're still going to do the vertex. Okay, so what we're saying now is you can get the vertex by doing negative b over 2a. Now this is the new method. Comma, whatever you get when you plug that back into the equation. Okay, so this is my x coordinate. I plug it back into the function, whatever that number is, it's just a number. Plug it in, and whatever I get back, that's my y coordinate. Okay, that's the vertex. We also have this thing here that's called an axis of symmetry. It's a line where things are going to be the same on both sides. So axis of symmetry. And it's always going to be x equals, Because remember, a vertical line means you go through the x-axis at some number. What number are we crossing the x-axis at? Whatever that number is right there. Negative b over 2a. All right, so that's our main thing to look at for today. How do you find the x-intercepts? Where's the vertex? Where's the axis of symmetry? Let's do a practice problem. All right, let's see if we can find the vertex, the axis of symmetry, and the x-intercepts for this function. And when we're done, let's also go ahead and graph it. I think once we have all that information, we should be able to draw a picture pretty easily. Okay, you guys go ahead and try it. All right, so I'm going to start with where's the vertex, because that's what's easiest, it's what they asked for. So I know the vertex is at x equals negative b over 2a, which is going to be a negative 8 over 2 times 1. That's going to be a negative 4. That's where my vertex is. So what is f of negative 4? Plug it in here, I get 16 minus 32 minus 9. So let's see, that's going to be a negative 16 minus 9, that's a negative 25. There's my vertex. Negative 4, comma, negative 25. All right? And so then they also ask us to find the axis of symmetry. So the axis of, I'm going to abbreviate this, SYM, is at x equals negative 4. It's always x equals whatever that number is, right? Because every parabola is going to run up or down like this, or like this. That axis of symmetry is going to go right through the vertex, and it's going to be the line x equals whatever we're going through on the x-axis, which has to be the same as the x-coordinate of the vertex. All right, so now I need to find the x-intercepts. All right, so I've got x squared plus 8x minus 9. I'm going to set it equal to 0 and solve because zeros are the same as x-intercepts. All right, if I'm finding a 0, I'm trying to find out where does y equal 0. So I'll make 2 sets of parentheses. That's x times x. 2 numbers you multiply to get 9 and subtract to get 8. Sounds like a positive 9 and a negative 1. So that means x equals negative 9 or positive 1. Those are my x-intercepts. And so now I want to draw a graph. All right, so if I'm drawing a graph here, so to get to negative 25, I'm going to have to count by something different. So I'm going to say that on the y-axis, I'm counting by 5s. So negative 5, negative 10, negative 15, negative 20, negative 25, right there. On the x-axis, I got to get at least to negative 9, so I'm going to count by 2s. I don't have to count by the same thing on both axes. It's okay to count by one thing here and something else here. All right, so where's my vertex? Negative 4 comma negative 25. So remember, I'm counting by 2s. So that's negative 2, negative 4, 5, 10, 15, 20, 25, right there. My a value was positive, so I know the parabola opens up. And I also know I need to go through these points on the x-axis. So here's 2, 4, 6, 8. There's negative 9 right there. Positive 1 is right here. I know exactly what this parabola looks like. It's going to go down like this, turn and come back up. And then if they ask me to label the axis of symmetry, then what I'm going to do is I'm going to take a dotted line. I'm going to go just like this. I'm going to call that line x equals negative 4. There, I've labeled it. Probably should put arrows here because we know the parabola goes on forever, so does that axis of symmetry. Saw a lot of homework problems the last time I checked them where there's no arrows on here. Make sure you put those on there, okay? It's got to be there. All right, let's try another one. All right, so here's another problem. It says to find a quadratic equation. Now, we want to make sure that when we see the words quadratic, we feel comfortable with that. A quadratic equation is just y equals ax squared plus bx plus c. I don't know why they call it quadratic. Quad to me means four. I know quad is a four-wheeled motorcycle. A lot of people like to use those to race around the dunes. Maybe it's quadratic because there's 1, 2, 3, 4 terms. I don't know. But when they say quadratic, that's what we're talking about. All right? So they want us to find a quadratic equation given these 2 points. The vertex is at 4, -1. And there's a point somewhere else on the graph, on the parabola, that's 2, 3. And they want us to find the equation. So here's what I think is the easiest way to do this. I think the easiest thing is to start with our equation in vertex form, or standard. So I'm going to say y equals a times, remember how we said that it's always a good idea to let b equal 1 if you have the choice? Well, we do here. I'm going to let the a value control how many times more or less than what's normal. So I'm just going to go x plus the c value squared plus d. Okay, we're going to let b equal 1. So what I'm going to do is, if I know where the vertex is, that means that this equation right here is now a times x minus 4, right? We've got to do the opposite, what we see there, squared minus 1. There's my d value. So the only thing that's really missing is the a value. But I've got another point here. I've got an xy coordinate that I could plug in here and here to figure out what the a value is. So we'll let y equal 3. We'll let x equal 2. And I should be able to solve for a. So let's see, if I subtract that, that's a -2. Square it, you get 4. So I've got 3 equals 4a minus 1. I'll bring that 1 over here and add it. So I've got 4 equals 4a, a equals 1. That tells me this is a normal quadratic equation. Okay? So over here, I'm now going to say that my equation is y equals, a is 1. So I've got x minus 4 squared minus 1. The only thing is when they ask a question like this, find a quadratic equation, they really want it in general form. Ax squared plus bx plus c. And so I just need to get back to that point. So I'll go ahead and square this. Square the first term, multiply the 2 and double it. Square the last term, you get plus 16 minus this 1 that's out here. And so my final equation is x squared minus 8x plus 15. There's my quadratic equation. Okay, let me give you guys one to try. All right, you guys go ahead and try this one. All right, so I'll try to make this one go a little faster. If I know where the vertex is, I've got y equals a times x plus 2 squared. Remember, I got to do the opposite of this to get to here. Plus 1. And then I'm going to take 1, 3 and plug it in here. So my y value will be 3. I've got a 1 right here. So let's see, 3 squared, that's 9. So I'm going to get 9a plus 1 equals 3. Bring that 1 over and subtract it. I get 2 equals 9a. And so divide by 9, I get a equals 2/9. Aha! This parabola is 2/9 of what it normally is. Numbers are starting to get messy. Okay, remember, pushing things a little farther each time. So I now know that what I have is y equals 2/9 times x plus 2 squared, what was that number, plus 1. And I want to convert this back to general form. So first thing I need to do is I need to square this. So I've got y equals 2/9 times square the first term, multiply the 2 and double it, and then plus 1. Now distribute 2/9 times each of these. So I get 2/9 x squared plus, if I take an integer times a fraction, we just multiply that straight into the numerator, right? Because this is 4/1. So 8/9 times x, multiply 4 again, I get plus 8/9 plus 1. And so my final equation is going to be 2/9 x squared plus 8/9 x. Make sure those x's are real big. This will be 9/9 plus 8/9. That's 17/9. There it is. All right, so remember I told you guys, I know we just took a test, but here's our video for Monday, Tuesday. There will not be a video tomorrow or Wednesday this week because it's a day off, it's Veterans Day. So, you know, we have through Wednesday to try and get done with this, all right? So we're on week 9 now. This is page 134, 135. We're going to do 20 to 26, 33, 43 to 49 odd, 59, 61, and 62. All right, there it is. You guys take care, enjoy your day off, stay safe, and see you on Thursday and Friday. Bye.